Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 20, estimating a population proportion. In a previous lesson, each student in your class selected a random sample from a population and calculated the sample proportion. It was observed that there was sampling variability in the sample proportions, and as the sample size increased, the variability decreased. In this lesson, you will investigate how sample proportions can be used to estimate population proportions. Example 1, mean of sample proportions. A class of 30 7th graders wanted to estimate the proportion of middle school students who are vegetarians. Each 7th grader took a random sample of 20 middle school students. Students were asked the question, are you a vegetarian? One sample of 20 students had 3 students who said they were vegetarians. For this sample, the sample proportion is 3 out of 20, or 15%. The following are the proportions of vegetarians the 7th graders found in 30 samples. Each sample was of size 20. The proportions are rounded to the nearest hundredth. So here they are. So we're going to use this data to answer these questions. Exercises 1 through 9. 1. The first student reported a sample proportion of 15%. Interpret the value in terms of the summary of the problem in the example. So that means that 3 of the 20 students surveyed responded that they were vegetarian. Number 2. Another student reported a sample proportion of 0. Did this student do something wrong when selecting the sample of the middle school students? And the answer is no. This means that none of the 20 students that student surveyed said that they were vegetarian. Number 3, assume you are a part of this 7th grade class and you got a sample proportion of 0.20 from the random sample of middle school students. Based on this sample proportion, what is your estimate of the proportion of all middle school students who are vegetarian? Okay, since a sample proportion is a representative of the population, you should say my estimate is 0.20. Number 4 says to construct a dot plot of the 30 sample proportions. Okay, so I brought in, this is what it should look like. So the reason it only goes out to 30%, I copied over the data from the first page. The largest is 30%. So we're going to do a dot plot from 0% to 30%. So 0.15 would go here. 0.1 would go here, 0.15 here, and so on. 0.1, 0.1, 0.15, 0.15, 0.1, 0.1, another 0.1, 0.05, and then 0.2. So that's the first row. We're going to continue doing this. 0.25 is the next one. 0.15, 0.25, 0.25, 0.3, 0.2, 0.1, 0.2, 0.05, 0.1. 0.1 again, 0.3, 0.15, so I'm right here right now, 0.05, 0.25, 0.15, 0.20, 0.10, 0.20, and 0.15. So that's what our dot plot would look like. So now that that is constructed, we can answer questions about it. So it says to describe the shape of the distribution. Okay, so it's nearly symmetrical, mound-shaped, centered at approximately 0.15. Okay, 6 says, using the 30 class results listed on the previous page, what is your estimate for the proportion of all middle school students who are vegetarians? And explain how you made this estimate. Okay, so about 15% would be the estimate for the school, because the sample is 15%, so the sample is supposed to represent the population. And it says, I chose this value because the sample proportions tend to cluster between 0.1 and 0.15, or 0.1 and 0.20. Number 7, calculate the mean of the 30 sample proportions. How close is this value to the estimate you made in exercise 6? Okay, so we need to calculate the mean. So I need to bring this down so I can see it. So we're going to calculate the mean of these values here. So let me just put them here. Okay, I'll put them down here so we can see them. All right, so what we need to do is add these all up and then divide by 30. So 0.15, 0.10, 0.15. I'm going across 0.00, 0.10, and there's 5. I'll do 5 at a time, and that would give me 1, 2, 3, 4, 5. That's 0.5. Okay, so that's the first 5. So I'm here. And now 0.15, 0.10, 0.10 again, 0.05, and 0.20. 5 and 5 is 10, carry the 1, 1, 2, 3, 4, 5, 6. I got 0.6 from those 5. So now I'm here. Now I'm down here. 0.25 plus 0.15 plus 0.25 plus 0.25 plus 0.30 gets me to here. And that's 5, 10, 15, 20. Carry a 2, 2, 4, 5, 7, 9, 10, 11, 12. I got 1.2 from that group. Now I'm starting here. 0.20, 0.10, 0.20, 0.05, and 0.10. So I got a 5, and 2, 3, 4, 5, 6. So I got 0.65 for that one. Okay, so that put us to here. Now in the last two, 0.10, 0.30, 0.15, 0.05, and 0.25. 5, 10, 15, carry a 1, 1, 2, 5, 6, 8, 0.85. So now I'm here, last 5, 0.15, 0.20, 0.10, 0.20, and 0.15. 5, 10, carry the 1, 2, 4, 5, 6, 7, 8. I got 0.80. Okay, now I'm going to get this out of the way. Okay, so now I need to add these all up. So 0.50, 0.60, 1.20, 0.65, 0.85, and 0.80. So that's 10, 5, 6, 12, 14, 28, 36. So it's 3.60. And then I need to divide that by 30. So 30 goes into 3.60. It won't go into 3. 3 goes into 36 once. So that's 30. Subtract, get 60. And I got a 2. Okay, I think I made a calculation error because I entered all of these values in my calculator just to double check. And the way I did it was, if you have a Texas Instruments calculator, TI-83 or 84, then you hit Stat, and you click, and it's already at Edit when you do that, so you just hit Enter. And then it gives you List 1. So there's 0.15, 0.1, 0.15. So I entered them, and if I go down my list, these are the number of items in my list. So as you can see, I've entered all of these values all the way up to the 30th, which is 0.15. Then when I finish, I hit Second Quit to get to the home screen. And then I hit Stat, arrow over to Calc, which means calculate. And we're dealing with one variable statistic. So I hit Enter. List is from L1. Frequency list, you just leave, calculate, and you hit enter. And I got the mean, which is the x with the line over the top. It's called x bar, is 0.153 repeating. So if I go back here, I should have 0.153 repeating. So somewhere I made an addition error. The answer is, the mean is approximately 0.153 repeating. And it says, calculate the mean, how close is the value to the estimate you made in exercise 6? And it said about 0.15, so 0.153 is very close. Okay? Okay, so going back to find my error, the sum of all the x's was 4.6. So now I know what I did wrong. I got 3.6. So when I added, I have 6, 12, 14, 28, 36. I did not carry my 3, I carried 2. And that should have been a 4. So that's the only mistake I made. I always like to find my mistakes. I don't let things rest until I know what I did wrong. So when I take 460 divided by 30, I would get 0.153. Okay, moving on. Number 8. The proportion of all middle school students who are vegetarians is 0.15. This is the actual proportion of the entire population of middle school students used to select the samples. How the mean of 30 sample proportions compares with the actual population proportion depends on the student samples. Okay, there's a misprint here. There's something missing. So I think the word does should be here. How does the mean of the 30 sample proportions compare with the actual population proportion? No, it says how the mean of the 30 sample proportions compares with the actual population proportion depends on the student samples. Okay. Okay, so in this case, the mean of the 30 sample proportions is very close to the actual population proportion. We're only off by 3 1,000ths. Number 9, do the sample proportions in the dot plot tend to cluster around the value of the population proportion? Are any of the sample proportions far away from 0.15? List the proportions that are far away from 0.15. So we look here, and yes, they are clustered around 0.15, but there are some that are away from it as well. 0.3 is quite a ways away from 15%, 30%, and 0% is quite a distance from 15%. So what I would say here is they cluster around 0.15, the values of 0 and 0.30 are far away from 0.15. Okay, example 2. Estimating population proportion. 200 middle school students at Roosevelt Middle School responded to several survey questions. A printed copy of the responses to the students gave to various questions will be provided by your teacher. The data are organized in columns and are summarized by the following table. Okay, so the question that I would have provided, and that's provided for this example, is the last column in the data file is based on the question, which of the following superpowers would you most like to have? The choices were invisibility, super strength, telepathy, fly, or freeze time. Okay, so there it is down here. The class wants to determine the proportion of Roosevelt Middle School students who answered freeze time to the last question. You will use a sample of the Roosevelt Middle School population to estimate the proportion of the students who answered freeze time to the last question. Okay, so if you go to the end, let me see if it shows it in the student version. It does not. Okay. Okay, so here's just a snippet from the teacher edition that they have. So the students have an ID number Travel to school by what means of transportation? And the first 12, most were car, one walked. Favorite season? Okay, spring, summer, fall, winter. Allergies, if they have allergies, yes or no. Favorite school subject? Okay. Um, Only one who likes math as favorite. That's pretty sad. Anyway, favorite music? No rock and roll. That's too bad too. Superpower, freeze time, telepathy, fly, invisibility, freeze time, and so on and so on and so on. So this continued, and I can't show you all of it because it's very lengthy, but there are 200 entries. And obviously, if I were in the classroom, I would have projected that. But anyhow, we're going to work with that data. So numbers from 1 to 200 are the IDs. Travel to school methods are walk, car, rail, bus, bicycle, skateboard, scooter, rollerblade, or boat. Boat. Okay, favorite season, summer, fall, winter, spring. Allergies, yes or no. Favorite school subject, and there's a list of subjects. Favorite music, and there it is, some heavy metal, yeah. Rock and roll, yes, okay. Others are good as well. What Super Bowl would you like? Invisibility, super strength. Telepathy, fly, telepathy, fly, freeze time. Okay, so anyhow, a random sample of 20 students' responses is needed. You are provided the random number table you used in a previous lesson. A printed list of the 200 Roosevelt Middle School students is also provided. In small groups, complete the following exercise. Select a random sample of 20 students represents from the data file. Explain how you selected the random sample. Okay, so generate 20 random numbers between 1 and 200. The random number chosen represents the ID number of the student. Go to that ID number row and record the outcome as yes or no in the table regarding the freeze time response. So in the table below, list the 20 responses for your sample. So what they mean is, what I would do is, you can use your table, of course, and drop your eraser like we did in previous lessons, but I would clear this, and I would go to math, arrow over to probability, and number 5 is random integer, and I would choose the numbers 1 to 200. And I would hit enter, and I got 189. And then I'd go to the printout that this teacher is supposed to provide for you, and if I went to student ID number 189, I'm scrolling now on the other screen, 189, they said fly. Okay, so since that person said fly, what you're supposed to say is, in the table below, list the 20 responses for your sample. Okay, so freeze time is what we're looking for. Okay, freeze time. And fly is not freeze time. So I don't want to put what it says. I want to put yes or no. And since fly is not freeze time, I would put no. Okay, so just for time saving in the video, I copied a bunch of yeses and nos if I were to continue choosing random values and then going to see if they chose freeze time or not. So first time it was fly, so that's no, then yes, and then a bunch of no's, and so on and so on. So there will be the list I use for this video. So C says to estimate the population proportion of students who responded freeze time. So that's my yeses. So there's 1, 2, 3, 4, 5. By calculating the sample proportion out of 20. So it's 5 out of 20, which equals 1 out of 4, which equals 0.25. Part D says combine your sample proportion with other student sample proportions and create a dot plot of the distribution of the sample proportions of students who responded freeze time to the question. Okay, so I'm only going to bring an example in because obviously in a video I can't do a classroom setting with several people, so I will just bring in an example. Okay, so here would be a sample proportion. Okay, this is just made up. Obviously, I don't have 20 students with me right now. So here is the sample proportion in a dot plot. E says, by looking at the dot plot, what is the value of the proportion of the 200 Roosevelt Middle School students who responded freeze time to the question? So if I look at this, I'm seeing that it's centered, it's mound-shaped. The majority of the population is centered around 0.20 or 20%. F. Usually, you will estimate the proportion of Roosevelt Middle School students using just a single sample proportion. How different was your sample proportion from your estimate based on the dot plot of many samples? Okay, so students' answers would vary depending on their sample proportions, but for this example, the sample proportion is 0.25, which is slightly greater than 0.2. So up here, we got 0.25 from this list, which is a little bit greater than 0.2. So I was one of these. Part G says, circle your sample proportion on the dot plot. How does your sample proportion compare with the mean of all the others? Okay, so if I get rid of that and I circled I would say mine was one of the 0.25, so there it is. Okay, so the mean of the class distribution will vary from this example. The class distribution should center at approximately 0.2. H, calculate the mean of all the sample proportions. Locate the mean of the sample proportions in your dot plot. Mark the position with an X. How does the mean of the sample proportion compare with your samples? So we want to calculate the mean of all these samples on this dot plot. So I'm going to show you how to do that with a calculator. And I'm going to go to Stat, Edit, and I'm going to arrow up to L1 and hit clear, and then arrow back down and start over. So we have 0.5 or 0.05, and then I have 4 0.1s, so there's 4 0.1s. I have 1, 2, 3, 4, 5 0.15s. Okay, so there's 5 0.15s. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.2s. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 1, 2, 3, 4.25s. I have 1, 2, 3, 4, 5.3s. And I have 1.35. To calculate the mean, we go to our home screen, clear it, go to Stat, Calculate, number 1 for one variable statistics, and just enter through. And the mean was 0.2016. So it says, calculate the mean of all the sample proportions, locate the mean of the sample proportions in your dot plot, mark this position with an X. How does the mean of the sample proportion compare with your sample proportion? So 0.2016 would be just a little to the right of 0.20, and mine was higher, but the sample proportion of the classes was 0.2, so there we have our comparison. So 0.25 was slightly higher. Okay, that is the end of lesson 20. Go do your problem set.